In this lesson, we'll explore the raster toolpaths. Now, the 3D high-speed raster toolpaths are composed from a set of parallel passes with a step over along a line set at an angle. So if you're looking at a clock, 3 o'clock is 0 degrees, and 12 o'clock is 90 degrees. So obviously 45 degrees is more like, I don't know, 1:30 or 2 o'clock. So if we take a look at this surface right here, we'll explore specifically this surface just so we can get an idea of how the raster toolpath works. Now if I look at it from the top, right across in our x direction, left to right, is 0 degrees, and perfectly up and down is 90 degrees. So if we go to our toolpaths, and under 3D, if we choose raster, we can select just this toolpath as our machining geometry. And for our avoidance, we can pick this one here. And we'll pick this one down below as well, just so we can see the toolpath in this green surface right there. Under the control, we'll choose a boundary, which will be this. Notice we missed a little space there, so we'll make sure we get that. There we go. So that's our boundary. The tool we're going to choose is the same 3/8. We'll call this raster. And under the cut parameters, let's do a machining angle of about 40 degrees. And we'll tighten up the step over a little bit. We'll do 0.75. And we'll click OK. And we'll see here that this toolpath follows up and down that surface based on a machining angle. You'll notice back here we have some collisions in this area. So let's do a couple things. Let's edit the toolpath and add this as an avoidance, which of course will impact this toolpath in this area. But we can also adjust the angle. Maybe we want to go back and forth instead of up and down. Let's go into the model geometry, and under avoidance, we'll also add triple click and add that one. And I'm just going to guess here. I'm going to do 40 degrees plus 90, which is 130. And we'll see how that looks. And as you can see, the angle was too much. However, you can see the machining angle and how that gets impacted onto the surface. So of course we could estimate, we could measure it, or we could just eyeball it again and say, okay, let's make this 115. And while we're at it, we'll tighten up the step over a little bit and regenerate. So as you can see, the raster toolpath is simply a back and forth motion, so it's a parallel motion. And it's very effective on shallow and nearly horizontal surfaces, or steeper surfaces like this. And in many cases for these steeper surfaces, you don't want to go perpendicular to the angle. And so in this case, you don't want to go up and down like we were earlier. But as you can see, you can really adjust this raster toolpath based on the surfaces you need to machine. So in this lesson, we explored waterline toolpaths and hybrid toolpaths and equal scallop, and we did that by copying the toolpath and then making some minor changes and explored the differences. And then we finished this lesson by exploring the raster toolpath on one small area of this part. In the next set of lessons, we'll explore various toolpaths such as flowline and pencil toolpaths. These toolpaths are pretty specific, however, based on the geometry that you're trying to machine, they can be very effective at machining and finishing your part.